All right, here we go with lesson 2.3. We're going to be doing rotations. I can identify and draw rotations. So a rotation is a lot of times commonly called a turn. And a rotation is a figure that is rotated about a point. Now, most times we will rotate it around the point, which is the origin, and that's mainly what we'll be referring to, but just know that there could be rotations around other points, but that's something that we don't talk about a ton in this lesson. Rotations will involve many rules. We have counterclockwise, 90 degrees, 180, clockwise, 90 degrees, 180, and then we could talk about some 270-degree rotations, but I'll show you how to do those when those come about. So to start, let's talk about the rules. So if we are going to rotate something counterclockwise, we're going to use the rule, and this is 90 degrees, negative yx. And this is would basically be taking the starting points here, and we would be going counterclockwise 90 degrees. Now, I said I would mention the 270. I also want you to understand that if you went clockwise 270 degrees, you would end up in the same position. So actually, the 90 degrees counterclockwise rule, negative yx, coincides with the 270 degrees clockwise, if that makes sense. Rotating clockwise, similar, but just a little bit different. We're going to use y negative x, and like I just showed you, this would be a clockwise rotation of 90 degrees. This same rule could be applied to a 270 degree counterclockwise rotation. As you can see, they end up at the same point. So just kind of keep that in mind. 180 degrees is nice because it doesn't matter which way you go. If this is my axis here, if I rotate 180 degrees this way, clockwise or counterclockwise, it doesn't matter. You're going to end up in the same point, so therefore the rule will be the same. So no matter which way you rotate 180, you're doing negative x, negative y. All right, so what I have here is a point 5,3, and we're going to apply all three rules of rotation. So that would be 90 degrees counterclockwise, 90 degrees clockwise, and 180 degrees. So let's start with 90 degrees clockwise or counterclockwise. I'll abbreviate that CC. I'm going to use the rule negative y x, and I'm going to take the point, which is 5,3, and I'm going to apply that rule. And what I would do here is, it looks like the rule shows me that x and y flip-flop positions. So the 3 would come first, the 5 second, but then I also want to point out that within the rule, the y value is opposite. So that would be negative 3. Negative 3, 5. Let me see if I can correct this, 5. Okay. 180 degrees. Let's rotate that so it doesn't matter if it's clockwise or counterclockwise. So the rule for 180 degrees is negative x, negative y. So I'm going to take my original point, 5,3, and I will apply the rule. And if you notice in this rule, the x and the y are not flipping positions. They're staying where they are. However, both of them are opposite. So for this, the positive 5 would become negative 5, and then the positive 3 would become negative 3. And then the last one we're going to do is 90 degrees clockwise. And that rule, as you can see above, is y negative x. So I take my original point, 5,3, apply the rule, and the the X and the Y do flip-flop positions, but in this situation, the X is opposite. So I'm gonna put the negative sign on the X value, because you can see the X value was originally 5, what I highlighted there. So that flips positions and becomes opposite of what it was. All right, let's do these with a few kind of real examples like you're gonna see in your homework. So these take a little bit of time, so we're not gonna have as many problems, but just know that each problem will take a little bit of work. So let's start with A, B, C, and D. I'm gonna plot these points and label them. So A would be 3 to the left and 4 up. There's A. B, 1 to the left, 4 up. C, 1 to the left, 2 up. And then D, 4 to the left, 2 up. So there's my original figure. What I need to do now is look at, okay, what rule do I need to apply? And that's the 180 degree, either clockwise or counterclockwise, it doesn't matter. So that rule is opposite X, opposite Y. So what I'm gonna do then is I'll highlight my original points here, and I'm gonna take these original points, and then I'm gonna apply the rule of opposite X, opposite Y to each one of them. So A becomes opposite -3 and opposite 4. B, and then C, D, and if you'll notice, all these new coordinates are opposite X and opposite Y. And I like to say that rather than negative because it's changing the sign from what it was to the opposite of it. All right, once I have that, I'm gonna plot these new points. So A prime would be 3 to the right and 4 down. And B prime, 1 to the right, 4 down. C prime, and then D prime. And this becomes our new image. Okay. All right, let's take a look at the next one. We're going to plot triangle LJK. So first I'm going to plot the original points. So L is at -3, 3. J is at -3, -3, -1. And then K is at -1, -1. And then I am going to rotate this 90 degrees counterclockwise. So 90 degrees counterclockwise is the rule -YX. So I'm going to take that rule and apply it to these points right there. So each of those points is going to flip-flop positions. So a lot of times what I like to do is just take one of the, either the X or the Y, and just do them all at once. So I'll do this with L, J, and K. I'm going to take the X value, and it looks like the X value is going to stay the same, but it's always going second. It's always going into that position. And now the Y value is coming first, but it's going to be opposite. So I look at the Y value, but make it opposite. So 3 becomes -3, -1 becomes 1, and then -1 becomes 1. Now that I have these ordered pairs, I can graph those and see the rotation. So L prime would be at -3, -3. That's L prime. J prime would be at 1, -3. And then K prime would be at 1, -1. And this becomes our new image after the rotation. All right, thank you.